All right, welcome guys to another week here. You guys just finished up the week of pretty easy week of work, right? That was a pretty easy worksheet. I hope you guys remember from doing that while we were back in the classroom. That was kind of just a quick review because that will be on our test. The rest of the formulas here are also what is going to be on our test. These are the three formulas that we need to know for the test. I feel like I said test like 5 times right there. I probably did. Speaking of tests, I have it right here in my hands. It is 21 questions. One of the questions is matching, so within that one question, there's 8 matching. So overall, there's like 28 questions. It's mainly focused on energy. So that's why this week we're going to be going back over energy. We're going to be going back over kinetic energy and potential energy. So I broke it down here, and there is 19 questions on energy, 3 questions on the conservation of energy, 2 questions on temperature, thermal energy, and heat, 3 questions, so this is including the matching, 3 questions on conduction, convection, and radiation, which we're going to do next week, and then 1 question on work and machines. So really, there's only 1 question on work. So you need to remember this formula for that 1 question. The rest of the formulas here, this will comprise multiple questions. So you guys really need to know these formulas. We'll go over them again real quick. This week, you're going to have kinetic energy and potential energy problems. You're going to have 1 worksheet on that, and your other worksheet deals with temperature, thermal energy, and heat. I would not be too stressed about that section because we only have a couple problems over it. I will go over what you need to know specifically. That paper, though, is basically just definitions, and make sure you just read through that section. I still want you guys to understand what it's talking about. 1 quick question I asked you on that the temperature and thermal energy worksheet is which type of temperature unit doesn't have negative numbers. That's Kelvin. If you guys ever heard of Kelvin, absolute zero, if you ever heard of that, that's 0 Kelvin. So that's when like you can't get any lower than that temperature, basically. Like nothing lives below that temperature. Everything's dead by then. You don't really need to know too much about that, but that is a problem for your test, and I wrote that on your worksheet, so make sure you understand that. Let's go through these equations again real quick. So we have kinetic energy is half mass velocity squared. So m for these 2 equations, m equals mass. You only have velocity in your kinetic energy because kinetic energy deals with motion. Remember, that's something you really need to remember. Kinetic energy deals with motion. The faster you're going, the more kinetic energy you have. The slower you're going, the less kinetic energy you have. Okay? So V equals velocity. And then talking about potential energy or gravitational potential energy, this deals with height. Okay? That's something you need to remember. Gravitational potential energy deals with height. The higher you are up, the more potential energy you have. The more potential energy you have, that will convert to kinetic energy when you jump off a bridge into the water. Okay? So we have mass again for m. G is gravity. And remember, gravity is a constant. Gravity is never changing. On Earth, gravity affects everything the same, and that is at 9.8 meters per second squared. Let me just put it right here. Oh, not 9.8. I'll write it right here. 9.8 meters per second squared. Okay? And in this test, let me make sure I'm not showing it to you guys. Remember, in this formula, you can see gravity written as 9.8 meters per second squared, or Newton kilograms. you could possibly see this on your test. And by possibly, you will see this on your test. Okay? So when you see this formula, you can write gravity as this, but you're going to see it on your test as this. Okay? So don't get confused. Okay? This is newtons per kilogram. It comes out to be the same thing with the formula. So do not get confused on that. And then we have H is height. If you guys remember. So going back through them again. Mass is in kilograms. That's our unit for mass. Velocity is in meters per second. Kilograms, meters per second. Gravity is in meters per second squared, or Newton kilograms. Height is in meters. Okay. And then going down here for work. Oh, and then right. Remember, your energies they're in joules. Every type of energy is in joules. That's why when you transfer from electrical energy to thermal energy, or light energy into heat energy, and they transfer across because they're all measured in joules. Okay, so we can put joules for, or J for joules here. Work is also in joules. Okay, force is in newtons. F equals force. W equals work, and D equals distance. Okay, so distance, it's kind of just like saying height, right? Except height you're measuring vertically, distance you're measuring horizontally. That is also in meters. Okay, all right. These are 3 formulas that you need to know. I would write them down, and I would study them for a little bit. Where did my sheet go? Let me just make sure there's nothing else you need to know from that. And no. Okay. Let me see. There's something else I wanted to talk to you guys about real fast. Okay, also, do not get confused in the problems when it says 50 M. Okay, so I'm going to erase this, so if you guys need it, you can go back. We also have the triangle. You guys remember seeing that in class. This doesn't erase very good. Let's erase this half over here. So let's say we're talking about gravitational potential energy, right? So we have the formula again up here. Mass times gravity times height. Okay, if the formula, or if the question is saying he was at 50 meters high, it'll show 50 M in the air, right? 50 M. Do not get confused with this. This and this is not the same, right? This M is mass right here. This M is meters, okay? This will be your height. So just make sure when you're reading the problem, you do not get confused on that. I think some people have been getting confused when we did the GPE worksheet. Do not get confused on that. Also, you guys got a little confused on the worksheet with the conservation of energy. When it talked about plants and how plants take in energy, it asked you what type of energy they take in. A lot of you guys had photosynthesis. That's the process of converting the light energy into energy that the plants can use, the chemical energy the plants can use to live, right? That's the process, but the energy that the plants take in is light energy from the sun, all right? Okay, lastly, about conservation of energy, I did not mention this the other day or last week, but the conservation of energy is the total amount of energy in the universe. And that total amount of energy always remains constant, right? Energy transfers from one form to another. Sometimes it's lost in heat, like in cars, the combustion engines, that chemical energy, some is lost through heat. But that doesn't mean that energy has been destroyed in any way. It's neither created nor destroyed, it's only transferred. So the total amount of energy in the universe always remains constant. You guys will also see that on your test. I don't really have any thing to talk to you about this section where you're getting into about temperature, thermal energy, and heat. It's pretty self-explanatory. There's no specific worksheet on it. I just give you guys definitions. You just have to read the textbook, but don't get too stressed on it because there's only a couple problems on the test on that part. Also, actually, maybe I won't get into that for right now. But if you guys have any questions with types of potential energy, let me know. Remember, there's different types. There's elastic energy, which deals with pulling a rubber band, right? When you pull a rubber band, you're gaining elastic potential energy. And when you let go of that rubber band and it shoots, that potential energy, because it was in a certain position, it was released. And when it started going into motion, it was that potential energy converted into kinetic energy. Okay, that's one type you guys need to remember. Excuse me. The other type is chemical energy. Chemical energy is like us eating food. Our body breaks down food, breaks down chemical bonds for energy. That's chemical energy our body uses. Also cars with combustion engines, they're breaking down the gasoline, breaking down the bonds in gas, and that's chemical energy that cars are using. Remember that, and remember you always need to give an example for these types of energies on the test, and gravitational potential energy as well. That deals with height. Remember, the higher you are, your position, it depends on your position. If you're higher up in the air, that means you're going to have more gravitational potential energy. Kinetic energy deals with motion, right? I think that's about it that I want to go over. Email me literally with any question you have. I'm available basically any hour of the day. After 7 p.m., that's when I really don't look at my phone as much. But yeah, just let me know. You guys, you're doing great. We only have a couple weeks left. Our test is going to be around May 20th or 21st, something like that. But it looks pretty easy. You guys are going to do great. See you later.